jump back to number 1 and talk about it? I will randomly call on people to answer. Number 1, Rachel wants to test how sunlight impacts plant growth over time. This sounds a little bit like what we talked about yesterday. She will add varying amounts of light to different plants. The sunlight is a what? First up is Andrew. Sunlight is a what? He says D, constant variable. Does anybody agree? Couple? Okay. Anybody disagree? Okay, those of you who disagree, shout out an answer.
C.
So you say C?
C.
C?
B.
Some say B?
C.
I heard C's, B's, and nobody said A. That's good. The answer is C. Independent variable. Remember, it's independent. It can change. Independent variables can change. And what we're testing is different amounts of sunlight. So we'll be changing the amount of sunlight the plants have. So it is C, the independent variable. Make sure you change it. Right, number 2, which is true about the scientific method? Janaya, what is true about the scientific method? D?
Yeah.
Are you Janaya? Yeah. The new Janaya, everybody. Luckily, the new Janaya is right. It is D. Good job, new Janaya. Next time, wait for your real name to be called. It is a series of processes which allow someone to make predictions, tests, and conclusions about a problem. If this was an EOG or benchmark, you could have figured that out just by the process of elimination. We know that a scientific method is not how we discover creativity in the lab. We know it's not a list of safety protocols. And we know it is not just used by certified scientists, because we're going to use it today. We're not certified scientists. So it's got to be D. If for some reason you didn't get this answer, get this sheet from me after we're done, because we're moving on. Carlos is trying to figure out the best place to put his router in order to get the best signal, which is not an independent variable. Before we talked about what the independent variable was, now what is not? Jacob, what is not the independent variable? Number walls. So C? Nope, not quite, but thank you for trying. I got my popsicle sticks now. Jose, what do you think? You now have a 70, nope, you have a 33% chance of getting it right because we know it's not C, so it's A, B, or D. He says B, and he is correct. Good job. Remember, independent variable is what we change. So we're looking for something that we don't change. We can change how far away your computer is from the router. We can change how many walls are between us and the router. We can do that by going to another room. We can change the number of devices on the router. You can have 2 computers and 5 Xboxes. You can have 1 Xbox, 1 computer, whatever. You can change that number. You cannot change the signal strength at the computer because that is what you are measuring. That is what we're trying to figure out. It's not what we're changing. We're changing everything else. Make sure you write down the correct answer. Last one. The following statement is an example of what? If I post an image on Instagram at 7 p.m., I'll get the most likes. Who's up? Who's up? Elijah C. What's the answer?
A.
He says A, hypothesis. Who agrees? Everybody should agree because it's the correct answer. Your hypothesis is a what? What's that?
Educated guess.
Is another way of saying educated guess. So I'm guessing that if I post something on Instagram at 7, that's when I get the most likes. My hypothesis may not be correct, but that is for the experiment to determine. Right now, I'm just making a guess. Today, you will be making your own hypothesis during a lab. The way warm-ups are going to work, we're not here Monday, so this is our Monday warm-up. You're going to put warm-ups on one sheet of paper. Friday, after our Friday warm-up, you'll turn it in. If you follow directions, write the question and answers when I tell you to, you get graded 100. If you decide not to follow directions completely, then you don't get credit that day, you get points off. Easy grade. It's going to be easy grade. It's what I call boosting grades. You just do it, and you boost it. I'll give it back. You put it back in your 3-ring binder. You use it to study. That's why I have you write the question and the answer. Because just writing the answer, that's not going to help you study. It's got a whole bunch of answers. No questions go with it. Question and answers help you study. All right, during lab time, if you need to get this from me to write down anything, you can come up here and get it. Real quick announcement about dismissal. If you are riding a bus for dismissal, you need to get to the gym as quickly as possible, and you need to sit down as quickly as possible. Make sure your friends around you are sitting down. Y'all need to handle that. Y'all need to be the example. Because we cannot tell Mr. Gaylor we are ready to dismiss until everybody's seated and everybody's in the gym. We're still waiting for people that are going and hanging out by the lockers. They're holding y'all up from going home. So make sure you go. Let's carry this conversation later. Come on, let's go. Sit down. Be cool. Notice we have not said anything about y'all having your cell phones. I'm not going to bring it up if y'all pay attention. Quit missing your buses. I'm just saying. There's like 5 of you every day. Just be cool about it. All right. So for those of you who turn in your safety contract, which is almost everybody, it's a good number, then we're going to be spending the rest of the time working on a lab. Who has done how many drops can fit on a penny before? All right, those of you who have done it, do not give it away to everybody else, okay? Shh. There's going to be a twist to this lab. I have modified it so that you have to tell me how it fits in with certain parts of the scientific method. First thing we do when we get our papers is what? All right. Now, no matter where you're at in the scientific method process, it always surrounds a question. So we're going to think about what our question is. And to find that out, we're going to be talking about surface tension of water. Does anybody know what surface tension is? I don't expect y'all to know, so don't freak out about it. It's something we'll learn about in the hydrosphere unit and in the chemistry unit. So don't worry about that. Y'all know what area is, right? Yeah, that's math. Surface area is how much area is exposed to the surface. So the only surface area I have on my box here is what's on the outside. Inside doesn't count as area. It's different from the area of the whole box. If I was to shatter this box, which I'm not going to because I like it, all these pieces expose more surface area. So we're not changing the mass of the object, but we're changing how many sides and pieces are now exposed to the air. Water surface tension is how water molecules hold together. Anybody ever seen like a drop of water on a leaf? Just like a perfect drop. It's not spread all everywhere. It's conglomerated together in a drop. The tension of the surface of the water is what holds it together. And I'm going to show you a picture of surface tension in action with the Olympics. This is an Olympic swimmer, and he is about to break the surface tension of the water, but he hasn't yet. When they took this shot, it's a pretty awesome shot. It looks like he's being covered by a blanket of water, and that's because he has not broken the surface tension of the water yet. He's a fraction of a second from breaking that tension, and then he's out of the water. You don't get it? So his face is covered in water. It's like he's got a blanket of water over him. It's like he's in a giant water drop. This picture is just perfectly timed to catch the tension of water. It looks like the water is stretching. We're going to test water tension, the surface tension of the water, by seeing how many drops can fit on a penny. And what you'll notice is, while you're doing that, it looks like you're getting a dome of water on the penny. At some point, that surface tension is going to break, and the water is going to spill out onto your desk. But we're going to test and see how many drops of water it takes to break that surface tension. So once you write down the definition of surface tension, and it seems like a very wordy definition. Formulate our question. Surface tension is the elastic tendency of a fluid surface, so not just water, but any fluid surface, which makes it acquire the least surface area possible. Basically, it's how much fluid molecules can stretch before they break apart and flow out from each other. And the surface tension will be different from water than it is from other liquid substances. Bless you. Now, in our experiment, we're going to be doing two different groups, the control group and the experimental group. In the control group, we're going, in our control group, we're just going to have water drops on a regular clean penny. In our experimental group, we are going to dunk our penny in a soap solution and see what happens to the water tension then. So what should our question be that we're going to ask in this experiment?
How many drops can hold on a penny?
Okay, how many drops can hold on a penny? What else?
What's going to happen to the penny once it's put into the solution?
I like a combination of those two. Between the two y'all got it on. Look. Does soap affect the surface tension of water? So we're going to see how many drops fits on a penny and what happens when we dunk it in the soap solution. Put those two together and we got our question. And this is what our scientific method is going to surround. That's one question. Now, based on what we just talked about with surface tension, that was our research. and based on what we already know, what we think, we need to come up with a hypothesis, and then you guys are gonna come up with your own hypothesis. I'm not gonna give it to you. And I want you to put it at the very top of your paper. So put H there and then write your hypothesis. So it's gonna be your educated guess to the answer of the question. And don't just put yes or no, that's not a hypothesis. It needs to be a statement. What you think will happen. The way this lab is going to work, you have to finish today. I will allow you to work in partners. Listen, not groups of 3, not groups of 4, partners. If you don't want to work in partners, you may work by yourself. Got plenty of slides away, doesn't matter to me. I will let you choose your own partners as long as you stay on task. If not, we're back to individuals where I'll choose your partner. All your supplies are going to be back here near Toothless. If you work in partners, you both do not need to come back here. Send one person so it's not such a crowd. In this bin, we have droppers for just water. We have cups to hold the water in, and you can get the water out of here because my sink's not draining very well today. And then I have a bag full of pennies. I'm not going to guide you through the steps of this experiment because this is a test of also how well you can follow written instructions. But do take a look at procedure part 1. It says wash a penny thoroughly with water and dry it with a paper towel. That means you can dunk it in the water that's in the sink. Make sure it's completely dry before you start your experiment. Make sure that your dropper only goes in the water, not the soap solution. When it's time to do the soap solution, all you're going to do is take your penny, dunk it in there, take it back to your desk, and then add water. You're not going to wipe it off or anything. Does anybody have any questions about what they're supposed to be doing? Notice at the bottom of your table, after you do each experiment 3 times, 4 times, you gotta get the average, calculate it back here if you need them. When you collect your data, there's gonna be 3 questions at the bottom that you're gonna answer yourself. And then when you're done, make sure your name is on your paper and you'll be turning it in before you leave the class. If you have questions, please raise your hand, but read the directions thoroughly first. The answer may be in there. All right, you may go ahead, get your partner and begin.